Recording. Okay. And all right. So there are going to be close to 18 people in this session. Actually, around 18 people have registered, and some people are from the previous batch. Okay. So welcome to the session, and just let me start. All right. So before we start the session, do you have any questions related to our previous session? No questions? All right then. Let me turn off all the devices. Okay. All right. So before we start with the discussion, I would like to know about you because we are going to be in this session for in this course for maybe 10 or 11 more sessions. So I would like to unmute you and you introduce yourself. Okay. And my name is Sandeep Giri. It shows Justin G, but it's because Justin G created the account for us on GoToWebinar. And I'm Sandeep Giri, and I have given my introduction yesterday. So, and I have been mostly into big data, and even before Hadoop was started. So I was working at DE Shaw, churning large amount of data on a grid of 10,000 computers. Okay, and after DE Shaw, I started a company called T-Bits Global. The company is running and is into the document management system. Afterwards, I joined InMobi and worked on big data technologies. Afterwards, I joined Amazon. At InMobi, I did a couple of recommendation projects. At Amazon, we I worked on a product called a product for optimization of images using a large cluster. Okay, that the product we built was similar to what you have Storm in open source, but we built something very specialized for Amazon. All right. So okay, so keep asking questions because that shows that you are listening to me. And all right, so that was my introduction, and we started No Big Data last year, and it has been close to 11 months now. 11 about to complete 12 months of delivering the courses. Okay, so that was myself, Sandeep Giri. So I'll start the introduction from Anuj Puram. Anuj, will that be okay if I unmute you and then you introduce yourself so that others can hear you? All right. Okay. So I'm going to uh, unmute Anuj.
Yeah, can everybody hear me? Can
Yeah, I'll tell.
can you hear me?
Yes, I can hear you, Anuj.
Okay. So I'm Anuj Puram here, located in Austin, Texas, USA. So I've come here to USA to do my master's in 2011 in University of North Carolina at Charlotte, and my specialization was computer science. So I finished my master's in 2012 December, and then joined ACI payment system, which completely works on banking solution. And I've been onto a project from then, which serves an online banking solution to various community banks here in USA. And as part of my job, I worked on different Java technologies like technologies and frameworks like JSF, Spring, and different databases like SQL Server and DB2. So I've been mostly onto the web application development and even some web services.
All right.
And I'm trying to look forward my career onto big data and Hadoop things.
Great to know know about you, Anuj. All right.
Thanks, Anu.
Okay, great. Thank you. So, Arvind, can I unmute you or yeah? Okay.
Uh, Hello everyone.
Yeah, I
Am
can
I
hear you.
audible?
Yeah, I can hear you.
Okay. Okay. My name is Arvind Maji. Currently, I'm working with theater. I have been into IT industry for over 8.5 years. Mostly, I have been into mainframe development. I started my career in Sintel. There, I worked for American Express. The solution was online applications uh, which is built in IMS system.
Mm-hmm.
Then I worked with HSBC.
Mm-hmm.
They they're the application was built in COBOL, X, and Vsam DB2. Uh, at present, I am working with one manufacturing company. The solution or the ERP system is built in mainframe.
All right.
IMS database and DB2 is used.
Okay. Okay.
Uh,
All right. All right. Great to know about you, Arvind. All right. I'll move on to Girish. Girish, is that okay with you? Yeah. Hariharan, is that okay with you? All right. Let me unmute Hariharan. So, just give an introduction, quick introduction in a minute. Yeah.
Yeah, I'm Hari, and I'm currently a graduate student doing masters in computer science. So basically, I'm very much curious on understanding in depth on how top tech companies handle scalability issues the most proper way. So that's why, I have enrolled into big data, and once I graduate, I like to have my career in the big data Hadoop line, being a developer.
All right. Great. Great to know you, Hari. And all right. Um, Girish, I will be unmuting you now. All right.
Yeah.
Yeah,
Okay.
I can hear you. Yeah. Hello. Yeah, Girish, we could not hear anything after that.
Yeah. Can you hear me now?
Yes.
Yeah. So I'm with IBM from past 12 years, and I'm basically I'm working in the CRM, CBL, and BI domain area. So I've been to the consultant, then architecting in the CRM and BI space, and last 4 years I'm doing the project management. So uh, now looking forward for the big data space so that I can utilize my previous experience and apply my skill here.
Great, great, great to know you, Hari. Girish. All right.
Thanks.
I will move to Shrisha. Shrisha, is that okay if we unmute you? All right. Yeah, go ahead. You are unmuted. Yeah. Shrisha, are you there? You are unmuted actually. No, we can't hear you. Maybe some technical problem with the mic. All right. All right. No worries. Okay, Kirupa, are you ready? So, yes, go ahead, Kripa.
Can you hear me, Sandeep?
Yeah, I can hear you.
Hello.
Yeah.
Um, hi, hi everybody. My name is Kripa J. I'm basically from Bangalore, but currently located in Pune. I started my career 3.5 years back with Emphasis Limited. I'm working since then with automation and manual testing. I would like to change my career path to development side. Since I did not get any chance to work on development here, I thought it would be a good idea to learn Hadoop and switch my career.
Great. Great to know you, Kripa. All right. Mandar, can I unmute you? And Michael? All right. So, yeah. So I'm unmuted you, Mandar. You can go ahead.
Uh, hi Sandeep. Are you able to hear me?
Yes, I can. We all can hear you.
Hi everybody. Hi Sandeep. Myself Mandar, and I'm having 11 years of experience, mainly into DB to UDB. I'm
Mm-hmm.
working as a database architect and database administrator currently working in TCS Pune.
Mm-hmm.
Mainly, I want to learn big data. I'm interested in NoSQL technology and big data technology from the perspective of a database. Already I know the RDBMS, so I want to learn how the big data handles the data,
Mm-hmm.
and in that perspective, I'm very much keen on that. So that's what I joined this class, and it's going good. Sandeep, yeah, yesterday's class was good. Yeah, thanks.
All right. Great. Great to know you, Mandar. And I'm unmuting you, Michael, now. All right. Go ahead, Michael.
Hello.
Yes.
Hi. My name is Michael. I'm a recent graduate from Iona College in New Rochelle, New York, USA.
Mm-hmm.
I did my undergrad for computer science, and I'm continuing to do computer science masters. I'm going to do a thesis on big data, cloud server security. Um, and big data is something I always really had an interest in, but my school never taught it. So I'm here to learn and try to get into the field.
Great. Great to know about you, Michael. It is definitely going to be fun. And stay tuned. All right. Great. Uh, so Praveen, are you okay if I unmute you? Priyabrat, Santos. So okay, I'm going ahead with the unmuting Praveen. All right. Yeah. Go ahead.
Hi everyone. Um, my name is Praveen Sipati. I'm working as a Java consultant since past 9 years. I'm located in Manchester, UK. So there is a lot of stuff going on, big data, Hadoop, NoSQL area. So just want to update my skills.
Okay.
So that's the reason I joined this course.
Great, great, great. All right. So, Priyabrat and Santosh, can I unmute you? Only two, three people more. All right. All right. So let me unmute Priyabrat. Yes, go ahead, Priyabrat.
Hi all.
Yeah.
This is Priyavrat. Presently, I'm located in New Jersey, US. Overall, I have more than 10 plus years of experience, and mostly I'm into QA and business analyst. So right now, I'm playing the role of a QA lead cum QA manager. So I'm looking forward to learn big data and use it as a like business analyst kind of role.
All right. All right. Great. Great to know you, Priyabrat. And all right. And Santosh, I'm unmuting you now.
Hi everybody, this is Santosh. I have close to 10 plus years of experience in mainframes, and I work for Walmart here in Arkansas, USA. I wanted to know big data and try to switch my career into big data Hadoop line. So I joined this class.
Great. Great. Great to know you, Santosh. Savita and Subareddy, can I unmute you? Yes, go ahead, please. Savita?
Hi Sandeep, you
Yeah.
can hear me?
Yes, yes, we can hear
Yeah,
you. You all can
okay.
hear.
Myself Savita Shetty. I'm currently located in US, Pennsylvania. I'm started my career in CGI as a mainframe developer, and I since then I'm working 10 years for mainframe, and then 2 years back I shifted my career to testing field, where I'm working as a QA manager for Geisinger here in US, and then I wanted to shift my career to big data, so that is why I joined the class here.
Great, great, great to know you, Savita. Subareddy, are you okay if I unmute you now? All right, there you go. So, yeah, go ahead, Subareddy.
Hi, this is Subhareddy. I'm working as a senior Java developer from last 10 years. Thank you.
Great, great to know you, Subareddy. All right, which organization do you work with, Subareddy?
I'm working for currently for MasterCard. So I've been working for different clients past 10 years.
Great, great. All right, so that was the introduction of almost everybody except for Pavan and Shrisha. All right, so we have a great class, 18 members in all, and all right. Okay, so we have Damodran also in the class who joined a little late. So should we go ahead with yeah, Damodran? Can I unmute you for a minute? Yeah. So when you were joining, we were starting, so that's the reason. All right. Good. Go ahead, please.
Hi team, this is Damodaram and call me Damo.
Mhm.
I am in San Jose working for Cisco for the past 10 years, and my experience is entirely different than this, but I work most often in Linux open software systems
Mhm.
in networking domain. So I'm curious to learn big data and those technologies, and hopefully if I can get a switch over to the technology. Thanks.
Great. Great. So that was Damodran. Great to know you, Damodran. And I'm sure you will like the whole technology stack. All right, then. Did I miss anybody else other than Pavan, and Srisha? All right. So great. Let's assume our usual discussion. Okay. So Yesterday we discussed the overview of the components. Do you any of you have any questions about about any of the components? All right, I think we missed Abhishek also. So can you go ahead, Abhishek, quickly? I'll just unmute you for a minute and then we'll continue the discussion. Yeah, I've unmuted you.
Hi, hi Sandeep, are you able to hear me?
Yes, I can hear you.
Yes, so I've been working at Cognizant for the past 2 years, and
Hmm.
I'm going to US for my higher studies in Masters in Computer Science,
Hmm.
and I'm looking to specialize in big data. I have learned R programming earlier, as my interest in data science was there.
Hmm.
So I want to complement that with knowledge in big data as well.
Great, great, great. All right, then you are definitely going to like the session. And great to know you, Abhishek.
Thank
All right, great. So that was the great introduction, and I'm very happy to have such a team here. And it is going to be a great discussion after all. All right. So yesterday we talked about all these components, starting with Hadoop distributed file system, but we did not go into the details of any of them. We just tried to describe them in a sentence or two. Okay. As we go forward, other than the components listed here, we will also go into one extra component called Zookeeper, and the discussion will in Spark is going to be little bigger. I mean, as planned. I mean, the way we had planned was 1 hour discussion on Spark, but it might go up to 3 hours because Spark is really growing good. Okay. For this particular session, we have decided to go ahead with a, a little more description of Spark. All right. So, okay. Yeah. So if there would be Arvind's question is there was some question related to sorting and data storing. Do not if you could not answer that quiz earlier, you can skip the questions or um, you can attempt it again after today's session. All right. And also, the question from Arvind that is it so that both HDFS and HBase store the data? Yes. Okay. Just like a normal file system like C colon, D colon, what you have in your Windows system, similar to that, we have HDFS and HBase is for storing the data in a tabular format like your databases do. All right. So that's as brief as I can be. All right, now the main component, which is our HDFS, we are going to go into the details of the HDFS. Okay, so now every now and then all of us would have this question that why do we need a newer file system? So instead of just going ahead and explaining to you the internals of HDFS, we would start with a quick exercise. Okay, and the exercise is as part of this exercise we ourselves will come up with the design of a HDFS kind of a system. Okay, and then will become a very natural that why do we have such kind of a new file system. All right, now question to all of you is, if you have 100 terabyte of data, how would you store it? Or in other words, in your local community, you decided that you want to build a data storage for storing all the movies, and you estimated that we would require around 100,000 TB of storage. Okay, now how would you build such a system which can store 100 TB, not 1000 TB, 100 terabyte of storage? Anybody? Please give it a thought and come up with your own solution. So it's like a practical problems which we all faced, and we solved it in one way or another. Not 100 terabyte, but maybe 10 terabytes. You all must have faced that. What if we could build such kind of a file system? All right. So please go ahead and pour in your answers. I would like to understand. If there is a doubt in the question, please let me know. I can clarify the doubt. Yeah. So Srisha says that we using network attached storage. Abhishek says that I would store it on 100 different computers, each having a disk size of 1 terabyte. Great. Savita says it's like a hash bucket where, based on the range of the key, the respective data will be into the hashed into a bucket, but is stored at multiple node, which means multiple computers or multiple instances. Great, Savita. And same is Srisha's solution also, using 100 systems, each with 1 terabyte disk. Okay. Michael says that I would build a home server, add multiple hard disks. Okay. So will you add 100 hard disk into a single computer, Michael? Or will you use multiple computers and distribute the disks? Giri says that data will be split into different directory structures. Correct. Damodaran says that distributed storage evenly distribute on 10 by 10 RAID devices with a G-Flash controller. Interesting, interesting. I'm not aware about G-Flash controller as such. Maybe I'll have to read it a bit. How does it work? Hariharan says have 1 TB hard disks in one data center and another 100 1 TB hard disk in another data center, and have the snapshot. Maintain a database to keep track of which data exists where. Brilliant, Hariharan. Anuj's question answer is distribute among different storage. Brilliant answers. I mean, when he says different storage, as in different computers. Giri says use a cluster. Mandar says a RAID. Okay, I think it's continued answer. Mandar says that he will use RAID 5 by 7 architecture. Okay, so all right. So Michael also suggests that he will use a multiple computer kind of architecture. Brilliant. So we have two solutions out of this discussion. One is a RAID based system. Other is the we call it the uh, individual disks attached to the network, or NAS or SAN, storage area network or network attached storage. Okay, so I will not go into the RAID kind of architecture because I myself am not aware about RAID solutions, because there are too many RAID solutions. I have used only couple of them. All right. Okay, what is RAID? RAID. RAID means redundant array of independent disks, or redundant array of I for integrated disk, or what is it? I don't know. So in case of a RAID, there is an architecture where that supports things like if you store the data in one disk, it gets copied onto other disks. Okay, okay, thank you, Hariharan. It's actually inexpensive. RAID stands for redundant array of inexpensive disks. All right. Great, great. So I will not be going into the RAID kind of a discussion, and maybe I'll need to understand it a little bit more to have a healthy discussion. All right. Now, Coming back to the general answers, the answer most of you gave is we will build network attached storage or storage area network, and that might look like the following. You will buy 1 terabyte hard disks and make 100 subfolders to mount these. Okay, and as an added advantage, okay, as an added protection, Hariharan suggests that we keep 100 more hard disk in another data center. That's also a very thoughtful way. Okay, so in this architecture, you see that what we did was we bought maybe some 50 computers. We put two terabyte hard disk in all of these, and then connected these computers in the network. And after we have connected these computers into the network, we have remote mounted or mapped these drives into a network folder, so that when you look at this network folder, you see these folders. If you try to write or create a file in these folders, that will actually go into some remote disk. Okay, so this architecture is probably clear to everybody, right? And this is how we did it traditionally. I was talking to a couple of my students who work at NASA, which is National Laboratories in US. So they still have this kind of an architecture. Okay, as an added protection, what they have done is, along with each hard drive, they have put one more hard drives on each computer, which is the backup of this hard drive, so that in case this hard drive crashes, there is a backup over there, kind of a RAID solution. All right, now the question to all of you is, do you see any problem with this approach? Good, good. Now, Mandar's point is that the problem he sees with this architecture is, how will the data be distributed? So no skewing should happen, meaning there will be, if we try to distribute data in this, okay, let's say we come up with a scheme that we will store the movies, or let's say we are trying to store movies, and we will store all the movies starting with A in drive 1, all the movies starting with B in Drive 2, but again, you will end up with very non-uniform distributed data, because in Drive 1, since there are a lot of movies starting with A, the Drive 1 will get full very quickly, while Drive 2 will be fairly empty. All right, very good point, Mandar. Damodaran says it's a serial access. Okay, okay. I would like to understand a little bit more. Okay. I think I understand it, but I would still like to understand a bit more. Santosh says IO might be expensive. Thank you, Santosh. Anu says that accessing the remote file may be slower. Good. Harian says accessibility issue. Brilliant. Savita says yes, one processor handling all these tasks. Correct. Pawan says that if we lose one drive, then that part of the data is lost. Brilliant. Data is not organized. Uh, why do I hear the noise? All right. All right. Now it's gone. Suddenly there was a lot of noise. Now, Savita's point is data is not organized across the drive. That is correct. Abhishek says if a computer is damaged, then both the main disk and the backup disk will get destroyed. Brilliant. Load balancing would be a problem. IO reads and write will take more time. Brilliant. This may not be an effective solution. Yes. All right. Yes. So Damodaran has clarified his answer saying uniform distribution of data is not maintained and hence the serial access will be there. Great, great. So yes, so you all have covered these problems. So first one is failover and backup. Even though we might be keeping backup of the drive on the same one, same disk, if that computer network is gone, then the access is gone. Similarly, how would you distribute the and in case of backups, there are multitude of problems. Your the hub might go haywire, the computer might go haywire, the operating system might go haywire, or the disk might go haywire. So there are multi-level of problems that could occur with respect to the outage. Next problem could be that the data may not be distributed uniformly. And third one is this the best value for money? Third one and fourth one are actually the similar points. Is this the best use of resources? Meaning you might be having say 500 GB drives lying around in your organization, but if you use 500 GB hard drive, there might be other problems in this approach. Okay, in this approach, like if you have bigger files, you won't be able to fit them into the smaller disks and so on. What about increasing accessibility? Okay, what about increasing accessibility? This is something you guys have answered, and this is very rare people answer this point. Increasing accessibility as in case everybody wants to watch a particular movie. Okay, today is Independence Day and everybody wants to watch a particular movie on Independence Day or a Christmas movie or maybe some actor's birthday or something, and people want to watch this particular movie. So at a time, if many people try to watch a movie, there are very high chances that that particular hard disk may not be able to cater more than one or two users at a time. Okay, it will be hard disk as well as the network that will be choked. Okay, because the same computer is trying to cater to all the users. So this is very very important, and this is something which we have to think again and again to solve. Okay, next is scaling out. Today we need 100 terabyte of storage. Tomorrow we might need 150 terabyte of storage. Now, how will we redistribute our files? How will we solve those kind of issues? All right. Yes. Manda says that bottleneck can happen if many people try to read on the same disk. Correct. Correct. So, is everybody clear about these limitations of this kind of structure? Also, if you have a file which is bigger than 1 terabyte data, that won't fit on these disks, correct? That won't fit on these disks. Make sense to you? All right. So the solution then is, are you convinced about these challenges with this? Great. Now, so keep responding, keep interacting. That makes me feel that we all are on the same page. All right. So the answer to these problems is HDFS. Okay. So we will go into the into the details of HDFS now. So all of you are ready, and some of you have already answered that have suggested that we create a central machine on which we will maintain the indexes, as in this movie is on this machine, this movie is on that machine. Okay, so we all are now in the okay. So the way HDFS guys designed, I mean, HDFS is based on Google's architecture of Google file system. The way they designed Google file system is similar to the same thing has been taken by Hadoop guys and implemented. And the design here is that in HDFS, we designate one machine as admin node or name node, although there is a backup before you ask the question. So although there is a backup of name node, so we have one admin node containing the information about the metadata. Okay, we will have one admin node having the metadata, and there are many data nodes. There are many data nodes which will actually store the files. Okay, so this admin node or name node is responsible for maintaining the list of files, maintaining the information about which file is on which data node. Okay, what is where. And all of these, whether it's a data node or admin node, all of these are basically a network service. Network service means they are running, these are the processes running in the background all the time, listening on a port and waiting to answer your questions. That is a service. So admin node, data node, all of them are a service. And one interesting bit about name node is that although the metadata or this index or the mapping is in the memory, but it keeps the whole data onto the disk as well. Okay. So that why it keeps in the memory, so that it can answer your questions really fast at a blazing speed. Instead of making you wait, it tries to answer as quick as possible. Because in case, since it's a singular machine who will answer to your questions, in case it gets overloaded, in case it gets blocked, then the whole performance of HDFS will go down. Okay. So data nodes store the actual data, while admin node store the information about the files. And the kind of information are we talking about? Okay, the kind of information is file name, folder name, and all that. We will again talk about what kind of metadata it has. All right, so these data nodes which store the data do not store the files as such. The files are broken into the blocks of, of 128 MB each. Earlier, the default block size was 64 MB, but now that default block size is 128 MB. So basically, a big file, say a 500 MB file, will be broken down into five parts. Okay, sorry, four parts actually. 512 MB file will be broken down into four parts. Similarly, say 400 MB file will be broken down into four parts. Okay, so a big file is broken down into the blocks of 128 MB each, and the this way we can fit really large files onto these data nodes. Okay. The other reason for there are many benefits of breaking down the file into blocks. First, it first it makes it fit the big file onto the small disk. Second, it leaves less unused space on the disk. fourth, it optimizes the transfer. Okay. Also, it optimizes transfer as in case one machine goes down, the parts will get transferred and all of that. Also, when a request for data comes into play, the whole load does not go on one data node. Imagine a movie of 1 gigabyte, okay, will get stored on 8 blocks, okay, which means there may be 8 data nodes from which the data will be read. So it's not only one computer. So some people who started just now, who started watching movie just now, will be putting the load on data node 1, and after some time when they finish watching the first block, the data node the second data node will come into picture. Why? And this way the load on your cluster gets distributed. Okay. Also, this block size can be increased or decreased per file basis. And if you try to decrease the block size, there'll be so many parts, so many uh, individual blocks. And and if imagine that if you decrease the block size to 1 MB, there'll be 1,000 blocks of 1 gigabyte file. Okay. So it wouldn't make much of a sense to have such a small block, because that will generate too much of metadata, too much of information. And when we say metadata also means which file is broken down into which blocks, and how are those blocks stored on these data nodes. Okay. So how are those blocks stored on these data nodes is also a metadata. Also, next thing is to understand is each of these block have multiple copies. By default, each of the blocks are replicated thrice, meaning total number of three thrice the storage it will consume. If you are trying to store 1 gigabyte of movie, it will consume 3 gigabyte of space on the cluster. So by default, the replication factor is 3, but you can control this replication factor per file basis. You can change, if there is some important file, you can change the replication factor to more than 4. But in case you have um, okay, if you have a less important file, or your cluster is very robust, then there is no need to create the replication factor. Okay. All right. Now, the other benefit of having replication factor is it distributes the load in the cluster. All right. Now, also please note that the copies of a block are always on different machine, because the backup or the copies of a block, if kept on the same disk, then the purpose of creating the copy is completely lost. Okay. So if a data node goes down, all the blocks that are stored on that data node are lost. But good news is there will be some copy of the blocks that are lost. There'll be some copy on some other data node. Okay. Again, again the same copy will be recovered from the other node, and the replication factor will again be brought to 3. The moment a data node is lost, the blocks will get lost, and those blocks that got lost, the replication and losing a block means that that block's replication factor has come down by 1. Okay. That can be again recovered using another data node, and this whole process is fairly automated. There is no human intervention required. So data node keeps on failing, you don't have to bother about anything. Okay. You just have to make sure that your file is intact, and once data node fails, you add another machine. Okay. And the whole system keeps on rebalancing itself. Great. Now Pawan's question is, where will the information about how the file has been splitted be stored? This information will be on the name node. This information is part of the metadata. Savita's question is, what happens when admin node fails? Are there disaster recovery failover for admin node? Yes, there are. Okay, we'll cover that aspect also. Now, Arvind's question is little pessimistic. He says that what about if all the three copies are lost? Good. Okay. So if all the three copies are lost, then it's a big disaster. All right. It's a big disaster. And if you have some suspicion of that sort, you should generally have a generally have replication factor of more than 3. Michael's question is, so you can copy a machine's block even if its machine goes offline? So, okay, let me try to understand the question. So, you can copy a machine's block even if its machine goes offline. So, if there is a big file and it has been put onto the data node, and a big file, say, there's a 512 MB file. Also, one more thing I forgot to tell you. All right, let me just increase the size. Okay, let's say you have got 500 MB file. Okay, how many blocks will be there? First block will be 128 MBs, 128 comma 128 comma 128, and last one will be 128 minus 12, that is 116. Okay, so all right, so there will be total 4 blocks for this particular 4 blocks, okay, of these sizes. Okay, and these blocks, the way they are stored on data node is like a file in the local file system. Okay, using whatever local file system, whether it's NTFS, FAT32, or whatever it is, these blocks will be stored there. Also, for each of these, there will be 3 copies. Okay, now in case let's say the node 1 goes down. Okay, node 1 goes down, and node 1 was having first copy of each of 4 blocks. First copy of each of 4 blocks. So immediately this data will be automatically copied to another node, say node number 5, and the copies of all these 4 blocks will again be regenerated. So can you copy a machine's data node even if it goes offline? No, actually, although you can recover, definitely recover. Now I understand Michael's question. Can you copy the machine's data even if it goes offline? So you may or you may not. If your machine has gone offline because of hard disk crash and there is no way to recover the data, okay, then you cannot really recover the data from there because you don't need to. That data is available on another data node. Okay. Shisha's question is, okay, Hariharan's point is that will 12 MB space be wasted or it will be used by other file? There is no such thing called wasting the space. Okay, because it's not like the block is reserved. The block is not reserved. There's no what do you call it, there is generally in the when storing the records we leave lot of unused space so that when the record expands we should fill the available space, and that's a common way uh, in which databases stores the records. Okay, here that's not the case. Under the hood these will be four files. First file will be having 120, first three file will be having 128 MB size each, while the fourth file would be having 116 MB size. All right. So there is no wastage of space. All right. So great, great. Now moving ahead. Now there is one more thing we need to understand. This is something which is not the way we have learned things so far. The way we have learned things is this, that user will come to name node, okay, and will ask, hey, name node, please give me my file. Now, name node, the impression we carry is that name node will do all the stitching and give back to you, but that's not the case. Okay, if HDFS was designed in this way, then name node will always be the bottleneck with respect to the network throughput as well as with respect to the CPU and the memory. Okay, so instead of this kind of model, HDFS follows this kind of model. There is a client driver which takes care of splitting the file and stitching the file. Okay, so user gives file to client. Client is like your JDBC driver or your ODBC driver. So user gives file to this driver which splits the data and which does all the communication between name node and data node. So this driver goes to the name node saying, hey, I want to store this big file. Name node replies back, okay, I have made a note of what you have just said. Okay, why don't you go on to the data node? These are the list of data nodes, and once you are done writing the data, you talk directly to data node, write the data there, and once you are done with writing the data to data node, come back and inform me. Okay, so this way name node has saved himself from the load. Name node has offloaded itself from the load which is going to be because of the transfer of the data. So name node says I am only bothered about the metadata and I will make sure the data is consistent. Okay, so again client driver would go to the name node and say, hey, I want to store this file, and the name node will redirect the client saying, why don't you go to these data nodes and store the file there, and once you are finished writing the data, come back and confirm to me so that i can I can mark in my metadata that this file has been saved successfully. All right, so this is how the client driver works. All right, the same thing is again represented in a little bit more complex fashion. Imagine that there is this name node over here and then data nodes here. Client comes to read the data or write the data. They first talk to name node and then they talk to data nodes. Okay, now Hariharan's question is, who slices the file into the blocks? Okay, that is the role of this client library. The client which you see here, client is the command you are going to use to interact with the HDFS. Okay, instead of saying directly ls, you will say Hadoop fs ls, which means you are telling this client called Hadoop to do the hard work for you. Okay, so whether you are reading the data or writing the data, you will always talk through the, the client or the library. In case you are trying to write the file using the program like Java or some other language, you will use a library for those languages. Okay. All right. So always it goes like this. The client writes the data to the data node, and this data it start get replicated. The blocks will start getting replicated by itself. Client does not have to copy it 3 times. These data nodes know each other and start copying the data to each other. All right. So that's another way of representing it, and we have already covered these operations. So the way it happens is the the HDFS client, the command line comes and says, hey, I want to create a file. The request goes to the name node, and name node responds back saying that please write the data to the data node. And now HDFS client would write the data to one data node that will be copied to other data nodes in this following manner. And once these data nodes have finished writing, they will confirm this individual data node. If it confirms the writing of the data, the request will go to name node saying, hey, I have finished the data, finished writing the data. Also, situations like if there are two clients trying to write to the same file parallelly, name node will block it. Okay, because everybody goes through the name node. Okay, now Anu's question is, how will the metadata related to replicated drives gets updated on name node? So for the first time, when the user comes and says, hey, I want to create this particular file. Okay, so name node tells that break this file into these blocks and go to these data nodes and come back and confirm to me. When this HDFS client confirms back to the name node, at that time name node makes the entry in the metadata. Okay. Arvind's question is, are data node related as linked list? Not really. It's more like circular. Data nodes each other, all data nodes know each other. Okay? Which means this third one also knows the first one. So all data nodes know name node, and all data nodes know each other. Okay. Now Anu's question is, what about the replicated data? Who updates the replicated data? So that again, since it's the name node which has told the data nodes that can you please replicate this particular file? Can you two guys coordinate with each other and replicate this file? Okay. So name node knows about all the information because it's the name node who is taking the call which data need to be replicated where. Okay. Data nodes are busy in copying the data while name node is taking the decisions. All right. Now Pawan's question is, so the client node outside the Hadoop system, client node is outside of the Hadoop system. That's correct. There is no client node. It's just a command. It's just a library. It doesn't run. Okay. Although this client library would be installed along with the data node and name node on all the machines. Okay. As well as this client library can be in an external world. Okay. Outside the cluster. Make sense, Pawan? All right, great questions. So Damodaran's question is block size same across the whole HDFS or the blocks made based on the input file size? So HDFS has a default block size. Okay, you can change that block size whenever you wish to change. Or if you want to change the block size for a particular file, you are free to do that. Okay, but by default, there would be some size on the basis of which it will be decided. Um, it, it will be decided that how big the block size is. But block size is never decided based on the input file size. All right. Okay. Now, Savita's question is, does the data copy replication has to happen in synchronous mode? Synchronous mode as in until and unless all the copying has finished, the response does not go to the user? Is that your question? If that is your question, then uh, answer is no. In the backend, the data nodes keep on copying and replicating the data. As soon as first copy is written, the customer gets or the user gets the feedback saying your file has been saved. Okay. All right. All right. So Damodaran's question is that if the block size is same for all the files, whether big or small, doesn't it deter the speed of access if it's not aligned on the default block size? Okay. So all right. So do you mean to say that had the block size been based on the file size, it could have been a better situation? Yeah. Okay. So I'll answer to your question, Damodaran. All right. So Damodaran's point is even 1 MB file will be saved as 128 MB block. No. 1 MB file will be saved as a single block with a each block size one block size with a size of 1 MB. It will not consume 128 MB. All right. So what is a block? A block is nothing but a file stored on the local file system on the data node. All right. And that will not be, if you have 1 MB file, it will be a 1 MB file. The block size will be 1 MB, not 128 MB. All right. So Hariharan, are you clear about the client or you want me to repeat that? Correct. So when we say block size, it's not your usual database block size. Okay. It's basically each block which is stored on each individual system is a file stored on the local file system, and the size, if you have only 1 MB file or 2 MB file, the size of the block will be 2 MB, not 128 MB. Great. So yes, you're right, Michael, because otherwise it will be too wasting of too much of space. CouchDB has a similar problem where they were consuming a lot of space just to keep a room for records so that they don't have to keep on moving the records. Same cases with MongoDB, but that's completely out of context. All right, now, okay. Now there is a Ashisha's question. Is the name or data node updates the backup name node? Yes. Okay, that we will discuss now. So, all right, and that is something I'll just stop for a minute and then, okay, all right. So I think let me answer all the question. We'll talk about rest of the things. Now the question from Srisha is the name node or data name node update the backup name node? So each of these, so every name node, generally in a high availability environment, what we do is we set up a backup name node. Okay, we set up a backup name node such that in such that when name node fails, immediately the backup name node takes the place of the name node. Okay, now how does the backup name node keep itself updated? Okay, the way backup name node keep itself updated is, or the name node keeps on telling the backup name node about all the information name node is getting from the client. Similarly, all the data nodes along with informing name node keep on informing the backup name node. This way the total load of transferring the information or transferring the knowledge about the data blocks is not only on name node, but the responsibility is also on the data nodes. The way data node inform name node that, hey, this is what has happened, this is something, this data node has gone down, all of that information is also shared with backup name node. So data node keep on informing, it's a part of design. All right, now Arvind's question is, does one data node knows about every other node in the system? Yes. Okay, one data node knows every other node in the system. Praveen's question is, will there be any configuration required for client node? Client node, there is no client node, it's just a client library. Okay, client library would be installed on all the nodes in the cluster, whether there is name node or not, but this client will be installed on all the machines. Okay, now the only configuration this client needs is who is the name node. Okay, and from name node it can find out about the data nodes. That's the information or configuration you need to tell HDFS client. All right, now Mandar's question is, how is the concurrency managed by name node? Name node is strictly concurrent, strictly consistent. Okay, it is strictly consistent in the sense that in case there are two requests coming to edit one file, it will stop one of them and only let it go only let one go. Okay, the other one will be in the queue, and the changes the other one is trying to make, in case those are not conflicting with the previous one, only then it will let it go. Otherwise it will give an error saying this file already exists, or the file you are trying to edit or change is being changed by somebody else. Okay, that's how the concurrency is maintained by the name node. All right, So Priyabrat, are you clear about the client node? All right. So Pawan's question is, so some type of file splitter program is part of each data node and working to split the file continuously. It's not running in the background. It's a part of your HDFS client logic. This library, this command called Hadoop has that logic. We tell this command, can you store this file? And it goes automatically to the configured name node, and name node tells it to split the file and store it here. And this particular command does the splitting of the blocks internally. Okay. Now, next question from Savita is that are the data compressed into the file system to save the disk space? So, good question. But HDFS doesn't make an attempt to compress the data by itself. Okay, but it provides a brilliant way of compression such as algedo, which we can specify while putting the data that I want to compress my file in algedo and then put it. Okay, you can compress your file before putting it into HDFS. So algedo is probably the most popular one because that's a splittable compression format, meaning in case you have splitted the file into blocks, still individually each block can be unzipped. Damodaran's question is the data node an intelligent device with media attached or just a storage device with storage logic? Good question, Damodaran. So data node is not a hardware per se. It's just a computer, and data node is a service. Just like a name node is a service, so you can install multiple other things on data nodes. Okay. So the way it happens generally is data node is fairly free with respect to CPU and RAM, but its disk is generally bigger and its IOs are really good. So on data nodes, we will also install the yarn component so that data nodes CPU and RAM will be utilized in processing. Okay. Savita's question is, are there any retry attempts? Suppose network timeout occurred, so successful attempt will persist the data into the respective data node. Okay, no, that kind of a fail-safe behavior is not designed into the clients generally. Okay, so those kind of things you need to try by yourself. Okay, the client will give an error, you can try and reattempt. All right. Hariharan's question is, will it have a costly performance for applications that require frequent writes like log files? Let me try to figure out from your previous questions. Okay, so Hariharan's question is, if you are continuously writing to a log file, will it have a costly performance for application? Brilliant questions. Now, uh, I mean, for the reasons like writing to the log file, because writing to the log file is a very continuous process, as in you keep on tailing a file, you keep on writing to the file, right? So if every time you're trying to write the file, it goes to the metadata and it tries to allocate this and tries to break the data and all of that loop, okay, it will be too time consuming. Okay, too time consuming and with performance wise. Therefore, Hadoop's HDFS provides an explicitly a function like append to the file. Okay, append to the file. All right. Because if you try to, generally the way it happens in HDFS, when you try to edit a file, you are basically writing the file again. Okay. Unlike a database, when you modify a table, it only modifies those few records that have been edited. In case of a file, whether it's Unix operating system or Windows, the way it generally happens is even if you change a single bit in the whole file is rewritten into the disk. Okay. So for the special cases like log file, where the data is only append only, in those cases, Hadoop has provided another function called append to an existing file, and you provide new bytes. And it's far, far, far efficient than rewriting the whole file. All right. Now, Mandar's question is, if somebody is trying to read the file which is being written, then what happens? Is dirty reads allowed or not? The answer is no. Namenode does not allow the dirty reads. Namenode is strongly consistent and therefore it does not allow the dirty reads. Now Srisha's question is, does Namenode allow more than one client to read same block of the data as in Datanode? Will Namenode allow more than one client to read same block of data as in Datanode? Okay. Yes, Namenode will allow that. Because if there are multiple readers for the same file and there is no writers locking the file, then namenode will allow all the readers to read the file. Praveen's question is, if it is a queue, will this not have a bad performance? Yes, that's correct. That's why namenode is not namenode tries itself to be very consistent and tries to avoid the concurrency issues or dirty read issues. Okay, so Hariharan's question is append to the existing file an API like call of Hadoop of the Hadoop client library? Yes. It is not only a part of the programming API, but it's also part of the command. So the way you say Hadoop, take my file and store it in HDFS, there is also a way saying take this particular file and append to an existing file. There is a command. Now, Anu's question is, so appending the text file will HDFS client still communicates to the name node? If that is the case, how is the append prevents the whole loop? Good question, Anus. So look at it this way. When you have just changed, added some more data, and you try to write that file onto the disk, the way it would happen is it will create the full file again. It will recreate all the blocks again. Okay. It will not try to do intelligent thing like diffing the blocks and figuring out what you have changed and what you have not changed. Okay. So it will saving a file is equivalent or editing a file is equivalent to rewriting the whole file. Okay. That is why append to the file will not overwrite the older blocks or will not recreate the older blocks. It will only create the newer blocks. And of course, the name node has to be informed invariably, just that the total traffic, total number of IOs will be far, far, far lesser. Make sense now, Anuj? Brilliant questions. Brilliant questions. So I'll just export all these questions and maybe put a blog or something. And yeah. All right. If any of you are maintain a technical blog, then you can do there as well. All right. Just so that your memory you remember the things correctly. In my previous one of my previous sessions, one of the student was maintaining a big Excel sheet with the questions and the answers, and that was really useful. I'll share that with you guys. And all right, great questions. Now moving ahead. All right, similar is the case of file read. Probably you have understood it by now. Also based on the discussion we just had, it's pretty clear that metadata means the name of the file, number of replicas, and then block IDs, and then the block locations. Okay, all of this information is part of name node metadata. Okay, so a quick question: if we say Hadoop, give me the list of files, are we talking to only the name node, or we will also talk to the data nodes? Anyone? We will be only talking to the name node. If we say, give me the list of files, we are not asking for content. Therefore, we will not be talking to the data nodes. All right, great answers. Okay, now Shisha's question is, it means writing into an existing file means creating a new file again and removing the old file. That's correct. If we try to edit a file and say this is my file, okay, and you say put my new file, that means you are basically going to overwrite the older one and rewrite the new one. Great. Even if you have just changed one bit of information. Now, why does the entire metadata need to be in the main memory? That's a kind of a call HDFS guys or Google file system guys have taken, because in case name node starts getting slowed down, then the performance is going to be the overall performance is going to be hurt really bad. Therefore, as part of their design decision to keep name node really fast, they kept the entire data into the main memory, assuming that even even a machine having 4 GB RAM can store hundreds of petabytes of data. Okay, that is the heuristics they computed, that even a 4 GB RAM can store humongous amount of information about the files. Okay, the only time it fails is that if you start storing millions of 1 MB file. Okay, let's say all the gifs or all the Facebook profile photos, you start storing them into the name node. So each of the file, whether it's 128 MB or 1 MB, although actual data storage on data node will be equal to the actual file, whether it's 1 MB or 1 KB, it will be 1 KB on each data node, but the metadata that is generated will be equivalent to the bigger files. Okay, why? Because a small file or big file has a file name, folder name, has a size, has a timestamp, and has other attributes, right? Therefore, it will have the equal amount of it will consume equal amount of metadata. So if you have 1 terabyte data of of 1 KB file, okay, so a terabyte contains 1000 gigabyte, and 1 million megabyte, and 10 to the power 9 kilobytes. So 1 terabyte data of 1 kilobyte files will cause 10 to the power 9 times the metadata of a single file, right? And therefore, in those cases, it will not be wise enough. Therefore, there are formats like tar and zip file in which you basically zip all these files together into a single block of file and store it. Okay, and that's why we always call that HDFS is not really tuned for very small size files. Okay, now Damodaran's question is, if I copy file A to file B, is file A physically copied to B and saved in the data store, or just the name node hash the metadata of A is updated with the address of file A? So if you are renaming a file A to file B, the metadata is generally updated. But if you are copying a file from A to B location, then the metadata is not updated, but metadata is replicated and the whole relocation of blocks happens. All right. Was I able to answer your question? Now, Michael's question is is the name node metadata written to the disk for backup in case all name nodes and backups go down? Yes. Yeah. So Michael's question is that is name nodes metadata persisted onto the disk, saved onto the disk for the cases for the rainy day, as in case the name node crashes? Yes, it does maintain a journal. It does keep a record on the disk. Okay. Hariharan's question is, what would be the configuration of name node and data node in the companies like Amazon? Okay, so generally we have really high-end servers as opposed to the common myth. So data node would be in like 8 GB RAM sizes, and name node would be actually a, a machine having maybe 100 GB RAM or 50 GB RAM, in that range. Okay, so name node in, if you think about Amazon kind of enterprises, we generally have name node in the range of maybe 50, more than 50 GB RAM, while data node would be something like 8 GB RAM. But in normal scenario, it is generally advised to keep data node with like 4 GB RAM, while the name node, you should have a really high memory system. Okay, CPU doesn't matter too much. CPU generally we have 4 core and sometimes we go for 8 cores or something. But the disk space of name node is comparatively low, while the disk space of data node is really high. Okay, disk space of data node goes into few terabytes. I mean, the disk space of data node goes into maybe 1 TB or 2 TB. So Pavan says that, do we have to instruct the name node when to tar and zip small sized files, or will it do it automatically? It will not do it automatically, and it will never do it for you. It is the Hadoop client which has these features. And also, even Hadoop client is not really equipped for those kind of things. It is your own libraries which will zip it and then hand over to Hadoop client, which will store it. Okay, so Shisha's question is, why do we need more RAM for data node? Not really. But 8 GB RAM is okay. Okay, 8 GB RAM is not considered more; it is considered medium when we talk about data centers. All right. But the only reason is why people keep more RAM on the data node, because data node will be used by yarn for computation. So that since data node contains data, instead of transporting this data to another machine and then processing it there, the computation is your code of MapReduce or other in other form will be sent to the data node for computation. Okay. Therefore, data node will be used for computation. It's not that data node will not be used for anywhere else. If we try to keep our computational node and data nodes on separate machine, what will happen is there will be too much of data transport from data node to the external machine. And that is where the cleverness of data locality comes into play. Make sense, Risha? Okay. Hariharan's question is, how many nodes does Amazon cluster have, or any other high-end companies in general? Okay. So we were running the detail page. We owned Amazon's detail page, and we had a cluster of around 200 nodes. Okay. Similarly, for image optimization, the image you see on the Amazon detail page, that we were running it on 30 machines, the image optimization alone. Okay. I hope that answers your question, Hariharan. All right, but those machines keep on changing based on festivals. If we have Christmas coming up or any local festivals coming up, we keep on increasing the machines. All right. And when I keep on saying we, I'm no longer with Amazon. I'm independent. So that we is not really a valid word. All right. So that is about the name node metadata. All right. So let's take a break of 10 minutes and then we will interact with our HDFS, and I'll just take you through how to find out where is our file and what is where. All right. All right. So I'm somehow not able to write anything. Hello. All right, let's start then. Should we start? Is everybody back? All right. All right. Okay. So before we move to the compute engine, let's just go through our Ambari, a quick overview. So although we'll come back to Ambari again, all right? So Ambari is a tool which can help you install the cluster very easily. Okay. The only thing you need to install at first is Ambari server, and whichever node you want to include in your cluster, you just install Ambari agent on all of those, and then tell Ambari server that these are the node that need to be added into the cluster. You all have to say add new host and provide the nodes on which you have installed the Ambari agent, and afterwards they will become the part of this cluster, and you can install which move install or whatever services or client you want from here. You can say add service and all of that. Okay, now here you have this HDFS. HDFS has got name node. Name node is up. Similar is secondary name node or backup name node, whatever you want to call it. And then we have four data nodes alive as of now. Okay. The memory consumption is this much, and it keeps on showing you the various statistics of the cluster. Okay, so Ambari not only helps you in provisioning, it also helps you monitoring the health of your cluster. So Ambari will be used by sysadmins. Okay, now there is another interface called Hue. Okay, all these passwords are mentioned in the document given to you in the in Hadoop installation document. So here you will see the using Hue, you can interact with various services. Hue is generally used by developers or analysts or mm, other operation engineers. Okay, so in this one, this is our HDFS. You see these files? These are other students' files. Okay, so you can either create your folder here, and if you want a separate account, just like a student, let us know. Because generally, uh, when we create the individual account, people find more challenges than using the same system. Because as we go forward, I'll be using this student account to access to demonstrate various things. Okay, so sometimes people find it confusing when they log in into their own personal account, they see nothing over there. That is why we kept a single login for all the candidates. All right. So here, as part of the exercise, this is our HDFS, and these are the files folders, and they look like usual files folder. You can see that there is one folder here. You can go into that folder and see that there has done something here. Okay, you can see that. And at the same time, you can basically upload the file or first create a directory with your own name so that your data doesn't mix with any other person. Okay, and you can upload the files using upload button and start using the cloud labs. All right, so if you go into here, no big data, and then my courses. Okay, under 11th July session, you will see installation document here. Okay, you will see the installation document. You can open that one, and under that you will see the URL, login, and password. All right, great. All right. So here you create before doing anything, you create your own folder by creating new directory, and then put an inside. Like for example, I have my own directory. And since it is multi-paged, you can sort it by date and twice so that these latest one will come here. Okay, you can see there the folder created by Kirti twice. All right, and so I have my own folder here. In this, I'll keep most of my sample data, which we will use for practicing. And okay, all right. So create your own folder so that we do not have to. Yeah, username password is again in the same document which we are talking about in this one. Okay, for all services, it's the same login password. Okay, you can see that. You can see here. The document is here. You can see installation instructions. You see, you click on open, and once it opens, inside it you can see that. Is it opening for you? Yeah. So what Mandar's point is that what needs to be done after directory creation, you can upload a file or two which is not very confidential for you, okay, into your folder. That way you will understand that you are able to upload the data. So Priyabrat, do you see 11 July here in the title? You are still seeing old page, as in what old page are we talking about? All right. Okay. So this is how you interact with the file system. Great. All right. Now, if you are on Mac or Unix, you can simply say ssh hadoop 1 dot no big data. Okay. Instead of saying this, a better thing would be this. Okay. Similarly, if you are using putty, if you are on Windows, install putty and connect to student at no, when in the host name type student at no hadoop 1 dot no big data or hadoop 2 dot no big data, anyone. Okay. All right. So here again, as you log in into Hadoop 1, you will again see another folder structure. When you say ls, this is not HDFS. This is the local file system of Hadoop 1. Okay, this is the local file system of Hadoop 1. So generally here you should create a directory like um, mkdir sgiri underscore local for your own self, so that you can distinguish whether whether you are in the local folder or you are talking about HDFS, to avoid the confusion. So this is the local folder. When I say usual, PWD means present working directory, ls means listing of the files. Here I'm interacting with the local file system of Hadoop 1 machine. Okay, this file system would exist even if there was no HDFS. All right. Yeah, 22 is the port number from putty, the usual one, default one. All right. Now here, when I have to interact with Hadoop, I always say Hadoop FS. And to see what are the various options available, you can simply say FS enter. And FS enter shows you all the options available to you. Okay. Whether you want to see the file, upload a file, delete a file, move a file, copy a file, change the permissions, change the mode, all of those commands are available here. Now, for example, I can say ls, and let's say some of us have created their folder, say brown 5k 1158. Okay, that's little complex, I think. Okay, so there is nothing in that folder. Okay, if I have to see my just do Hadoop fs minus ls, it'll give the whole list of HDFS files. You can see that these are the files. Okay, all right, so that is about Hadoop fs. So using Hadoop fs, we can interact with HDFS from the command line if you don't like this mode. Okay, and next is what was the next thing we wanted to discuss? Yeah, here. So let's say there is a particular file here, betting.csv is there. I want to find out, or let's say there was some nice file somebody has uploaded. Okay, let's say pig recommendation.jar. Okay, let's say this is the file we want to see what's going on in with it. All right, so what we will do is we pick this up and inside our command we just put it something like this. Okay, so there is other than our usual. Okay, now here, other than our Hadoop fs file, okay, Hadoop fs file, you can create, you can basically use another command called hdfs fsck for admin purposes. Now this particular command will tell us exactly where are the blocks of this file. Okay, you can see that for this particular file, these are the blocks available. Okay, here, from here to here, these are the blocks for this file. Okay, it shows that it has got a replication factor of 3 and it is lying on these machines. You see the IP address 107.170.180.232 and so on. These are the IP address of Hadoop 1, Hadoop 2 and Hadoop 3. Okay, Hadoop 2, Hadoop 3 and Hadoop 4. Okay, so it has stored, there is a single block. This is the ID of the block. You see, this is the block ID and it's stored at these locations. All right, make sense to you? So yes, Michael, it student means the we are trying to when we say student at hadoop1.nobigdata.com, it has to be .com after that. Okay, and in case the when you say hadoop1.nobigdata.com, it means that we are trying to connect to hadoop1.nobigdata via SSH or PuTTY, and we are trying to use a login called student. All right, and all right. Now, Pawan's question is: request your help to create my folder on training server. You basically you have to create it by yourself. All right. You log in onto Hue1 and then you can after logging in into Hue is running on 8000 port. Okay, so there are three gateways, three interaction points with our cloud lab. One is Ambari. With Ambari you can see what is the status of our cluster just for the monitoring purpose. With Hue, you can interact with Pig, Hive, and File Browser HDFS, as also you can see what is going on with Yarn and schedule a job. And Uzi is also there. So there are many ways for many tools for developers to use here. Okay. So once you log in, you click on the file browser and then create the folder. 50010 is the port of what service? Thank you, Damodaran, for asking that question. So basically, his question is when we look at this command here, it shows us something like 5001. You see this? This is the port number on which data node service is running. As I was telling you that every data node or every name node is basically a service running on the local machine. Okay, so you can basically check telnet localhost and check 50010, and it is connecting. All right. So basically that the port is for the great. Shisha's question is, what are the commands in the putty? These are the Unix commands. You can use the basic Unix commands like ls, pwd. Pwd is for present working directory. Cd is for changing the working directory. You need to get a little bit basic tutorial on Linux, and then you will be comfortable with it. All right, Srisha. So these commands which I'm running inside this terminal will be same for all of us. Okay, because everybody is logged in onto the same machine. Okay, so I can see who, and I can see that so many people are logged in from various places. Okay, there are somebody logged into ICE, open two terminals, and probably this is me. All right, good. Michael says that service server host key is not cached in the registry. I think, yeah, you will get it. No worries. Damodaran, you try putting in the port in the host name. Try to put student at Hadoop one dot no big data. Okay. Now, Michael's question is, can you talk about Ambari? What is it and how to get it? So, Ambari is this one. Okay, Ambari is the provisioning tool. Provisioning means it helps us install the whole cluster. Earlier, I was trying my best to use Cloudera Manager, as well as I was when I was building up Cloud Labs. I was trying out with the the uh, the default Hadoop instructions so that I can install it. But the way we had set it up in case of in Mobi was using Ambari. Okay, and that's why I went ahead with Ambari only. I found Ambari to be very user friendly. So Ambari is a way to provision or manage your whole network. Okay, or whole Hadoop cluster. All right. So, and you can basically download Ambari from their main website and then start using it. If you have downloaded Ambari and installed it, then you don't need to download Hadoop or anything. Okay. But if you are using Cloud Lab and you are okay with doing the way we are doing things, you should be okay. You don't need to do anything with respect to Ambari. Okay. But if you want to set up your own cluster, probably Ambari is the best way to do as of today. Okay, because I have tried all of the solutions and I found Ambari to be most user friendly. All right, great, great. So that was a bit about HDFS. I hope all of you got the hang of HDFS. So uploading, downloading file, all of those kind of thing you can do from the file browser. And also there would be one. Please, if you are not comfortable with regular expressions, go through this regular expression. Also, there is a Java course. You should go through that Java course also. Plus, plus Here there is a link called File Systems of Cloud Labs Explained. Okay. So generally people get confused with respect to the multiple file systems. There is a local file system on the desktop, there is a Hadoop one's file system, and then there is a HDFS. So to avoid that confusion, just go through this one and this one. I think they both are same actually. Both are same. This one and this one is both same. All right. And also now we will go ahead with our rest of the discussion. All right. Great. Now the next point which we want to discuss here is yarn. Now we discussed about HDFS so far. Should I move or do you have any questions? No questions? Great. Michael and others? Shisha, Pavan, Praveen, Damodran, Mandar, Priyabrat, Savita, Pavan, Arvind, Praveen, Anuj, Hariharan. So great. Oh, thank you, Mandar, for reminding me this question. I had somehow overlooked upon it. So, question from a Mandar which I skipped was all these nodes, data node and name node, do they need to be on the same hardware and the same OS level? The answer is no. Okay, that kind of abstraction is solved by running all of these things as a service. Okay, so these machines which are running as data node, they don't have to have the same specifications or same operating system for that matter. All they require is that the version of data node which is running on each machine should be identical. Okay, that's all. Although I have not seen anybody experiment on, although I have not seen any situation where the architecture of OS level or hardware level, the architecture of one data node is different from another. Okay, but uh, it should not be a problem per se. Okay, so Srisha, feel free to write to me if you have a problem. Okay. Yeah. So Mandar's question is okay. Yeah. Let me repeat what I'm saying. So as long as when you are installing the Hadoop on data nodes, right? As long as the version of Hadoop is same across the cluster, it should not be a problem. Whether it's Windows or it's Linux, one is on Linux, other is on Windows, it should not be a problem. So Michael's question is, will you show us how to install our own cluster on our computer? All right, that is something we do not do in this course, but let me think over it. Okay, but here in this document, there is a way to install it by the way of virtual machine. If you are okay with that, then yeah, you see the installation instruction here. Okay, here if you go scroll down, there is a way to install it on your computer using virtual machine on your desktop, and then you can install it on your machine. Okay, is this what you're looking for? Good, good. So no hurries. I will go at the pace at which all of you are comfortable. All right. Great. Now, this was how to store our data. If we have to process this data, we have moved to HDFS. Either when we have to process this data, what we can do is download this data onto your local machine and run our usual tools. But that is too inefficient. Okay. So that's where the compute engine comes into play. For two reasons. For two reasons, it will be too slow. First, you will be running it only on single machine, that is your computer. And second reason why this mechanism is slow, because we are dealing with big data and transport of the data over the network or internet is going to be very, very slow. All right. Now let's discuss about the compute engine. Okay. Is everybody with me? Yeah. All right, only Savita, Shisha, and Hariharan. Is everybody with me on starting with the compute engine, or you are lost with the? All right. Yes, you have the exercises here. In here, there's a quiz, and basically there's a quiz for today's session. All right, great. So everybody in line. Great. So again, let me talk about processing. When we talk about processing, the most common process form of processing is sorting the data. And when I say sorting the data, sorting the data is probably the most common form of processing. Okay, whether you are joining two tables, you are trying to group the tables, you are ordering the table, everywhere, almost every SQL query depends on sorting the data. That's why, let me ask you a simple sorting question. Okay, this is not to test your knowledge, but to test your to see whether you have a good estimation of the numbers. Okay, there is no maths around it, it's just a simple experience part. Now, if you have 1 gigahertz processor and you have to sort 1 terabyte data, and this terabyte data is in the form of you know, you can imagine this data to be 10 billion lines, and each line contains 100 characters. Okay, you have to sort this data, and the computer has only a RAM of 2 GB. How much time do you think it is going to take? Anybody? And this 1 terabyte data is stored on hard disk, not on solid state drive. Okay, Hariharan says n log n, as in 10 billion log 10 billion. Okay, but the thing is that's just a proportional number. All right, the problem is that n log n fails when we talk about big data, because most of the time is eaten by hard disk, most of the time is eaten by IO. Okay, so that whole analog and philosophy, the complexity thing from computer science takes the back seat when it comes to big data. All right. Shisha says that it will be more than 10 hours. And Hariharan says that it's plus the time to transfer the data between the RAM and the hard drive. Correct? And also keep into the account, Hariharan, the aspect like you will have this 1 terabyte data, you will have to slice it into parts. You will load each of this slice of 2 GB into the RAM, sort it, and put it back into the disk. So you have to write the data back into the disk. Mandar says may not finish with just 2 GB RAM. All right. You can, so I'm saying here that 2 GB RAM is free for you. The computer might be having any amount of RAM, but you are only given 2 GB RAM. All right, great. So we'll have to do something called external sort. So the approximate time is around 6 to 10 hours. Okay. Easily, it will take close to 6 to 10 hours. If you are really lucky. Okay. It might take a little bit more than that. All right. But if you try to do this way, that okay, for 1 GB, it took around 1 second to sort the data. Or for 1 GB data we just sorted it in 5 seconds. That means for 1 terabyte it will just take 5,000 seconds. Okay, but it doesn't work that way. So Michael is saying, how did you get to 6 to 10 hours? Basically, when I ran it, it took around 9 hours for me. Okay, there is no numbers, there is no computation here. Okay, so it's not based on calculation, it's basically for running after I ran it. All right. So what am I trying to say here is that when sorting 1 terabyte data will take 10 hours or maybe more, it may not be sufficient for lots of our problems. We might require a faster sorting, we might require a bigger data sorting, and we might require more often. All right, and that is the reason why, and sorting being a very important problem. And that is why almost everybody keeps on competing with sorting benchmarks. Google won the sorting benchmark in 2011 by being able to sort 10 petabyte data on 8,000 computers in just 6.5 hours. Okay. Now, sorting is a very important problem. Probably everything revolves around sorting. That is why Hadoop or MapReduce is basically a big, grand sorting engine. Okay. So again, when we think about a select query with where clause, if there are no indexes on the table, the where clause will take a lot of time. Therefore, we create indexes. And what is an index? Index is a sorted set of values. Okay, so to prepare it index on 1 terabyte data, it might take more than 10 hours. All right. Similarly, if you think about group by is nothing but sorting the data and then doing the group by. Similarly, when we join two tables on a particular key, the data on both the tables is sorted by that key and then it is joined. Okay, so effectively joining two tables is also a sorting problem. All right, order by is of course the very obvious one, is a sorting problem. So almost all these problems which we have just discussed is assorting or ordering the values, that kind of problem. Okay, and and that is the reason why MapReduce and almost everybody keeps on competing on sorting benchmark. All right, moving ahead. Now, as we saw that when we try to do this processing, i- and the only way to speed this up further would be, anybody, if we try to improve the processor, will the time come down? Of course no. You might bring down from 10 hours to maybe 9.5 hours by using a faster processor, but nothing more than that. Will increasing RAM make it faster? Yes, maybe. Okay. But reading the data from the disk will be the bottleneck in the game. Okay. By the time one process finishes reading the data from 1 TB, it will take far less time to sort that data. Okay. Therefore, Therefore, time is not consumed in sorting the data. Time was consumed in reading the data from the disk. Therefore, it's important to have multiple hard disks storing 1 TB data and multiple computers parallelly doing the things for us. And therefore, even if you use a simple supercomputer over here, you will not be able to reduce time beyond 4 to 5 hours. Okay, maybe not beyond even 6 hours, even if we are using a supercomputer. All right. Therefore, the only way to solve such kind of big data problems is by distributing work to multiple machine. Okay. Now, since our data is already distributed when we have put the data in HDFS, so why don't we take the advantage of that aspect? Okay. So that's where the compute engine of Hadoop comes into play. So in a compute engine, we will first talk about Hadoop 1.0, then we will understand the Hadoop 2.0 part. Okay. So stay with me. Earlier, the full compute engine was called MapReduce. Okay. But then it was split it into two parts. One was called Yarn, and the upper layer was called MapReduce. Okay. So this engine, the compute engine, is the upper part, and the lower part is our HDFS, which we have already seen. So generally what we do is, in the cluster we install the job tracker, and we install task trackers on the same node. Okay, I think I've jumped a little bit ahead. Okay, so the way we had one master node and other slave nodes in case of our HDFS, in the same philosophy, there is a job tracker and task tracker. In the computation engine, you have a single node called job tracker, and then actual workers are called task tracker. This job tracker does nothing but it accepts your job, whatever work you give to job tracker, it accepts it and then hands it over to all the task trackers so that your work can be executed in the cluster on multiple computers. All right. So job tracker will take your request of any work and then hand it over to all task trackers. And once all these task tracker finish their work, they will respond back to job tracker saying, "Hey, I am done." Okay. In the same manner, the same diagram can be done in this way. The client, which is the command line, which is being used by you, using the client, you hand over the work to job tracker. Okay. work to job tracker. Job tracker behaves like the manager of the shop floor, okay, who does nothing but takes care of all the workers on the floor, who interacts with the external world in order to get the work done. Okay, so job tracker will delegate the work to task trackers, and task trackers will report back to job tracker with the status. So yeah, Michael's question is Michael's question is, so the map reduce engine gives the data node a job or the task tracker a job? It gives the task tracker a job. Okay. Generally, the way we had data nodes as a process, we also have task tracker as a process. And as a thumb rule, we install task tracker and data node on the same machine. Okay. Every data node generally also have task tracker. So job tracker interacts with task tracker. It does not interact with data nodes directly. All right. Now the way it used to work is this. Also, the kind of job tracker performs is also all the jobs which are performed on a cluster also take the benefit of the data locality. What does it mean? What does it mean by data locality? It means that work will be given to only those task trackers which are closer to our data. Let's say you have 500 nodes in the cluster, okay, and your file is existing only on first two computers, okay. Now when you assign the work, say sort my data, the kind of work, say please sort my file, okay, this kind of work is given to only those task trackers which are very near to the file which you are trying to sort. Okay, so the processing work which is sorting is generally given to only those task trackers which have the data. Okay, all right, there are some questions. Girish's question is, client talks to job tracker talks to task tracker, and task tracker might be talking to the data node. That is correct. Girish? Now Srisha's question is, if the task tracker on one data node is busy doing something, can other task tracker on another data node access the data node block and process? That is correct, Sirisha. That's brilliant. So imagine that we had one block and we had 3 copies of it, right? Total 3 copies. So if we are trying to process our file, the file would be existing on 3 node. If let's assume that our file size is less than 128 MB for simplicity reasons. Let's say you have 100 MB file, and since it is got a replication factor of 3, therefore this file would be existing on 3 data nodes. Therefore generally 3 task trackers. Now you are really unlucky, and when you want to process this data, when you are trying to run some computation, all these 3 data nodes, these task trackers running on these 3 data nodes are busy. Okay, so the computation will be done on the node which is closest to any of these ta- task trackers. Okay, the closest to any of these task trackers, so that the transport of the data does not take much time. Okay, Mandar's question is, when we talk about near, what does it mean? Okay, near is based on the topology you define in your cluster. Generally, the way you lay out your cluster, generally the way you lay out your network is in the form of tree, and based on that tree, the you also tell Hadoop that this is our this IP address and this IP address are the children of this IP address and so on. And based on that, Hadoop takes a call of nearness. Okay, we will talk about this aspect when we talk about in detail how does data locality works. Now, Hariharan's question is, who moves the computation to the task tracker? It is the job tracker who moves the computation to task tracker, okay, not the client. Anu's question is, when the computation is done, will the replicated data node, when the computation is done, will the replicated data node get updated as well? Hmm. So do you mean to say when the computation is done, we have to store the result somewhere? Okay, all right. Correct, correct, Srisha. If I mean to say that task tracker on one node can access work on the other data node can work on the other data on other data node if all the task trackers on those data nodes are busy. All right. Damodaran's question is there multiple instances of job tracker for each file or one job tracker for all files? So one job tracker for all files. Okay. So there will be job tracker. When I say job tracker or task tracker, these are the services listening on a port, and they are fairly multi-threaded, and they keep on executing the processes in the background. So basically, when you hand over them the job, they do it parallelly because these are organizational wide services. In your organization, there must be 50 other people uh, trying to execute their work, right? Therefore, job tracker can handle multiple jobs in parallel. All right. Now, Anu's question is, when the computation is done, will the replicated data node gets updated as well? Okay. So, I mean, you mean to say that when computation is done, the result of the computation will be stored somewhere, right? And will that update? Yeah. So, Anu's question is, if there is some update on a data node during the computation, okay, so probably are you trying to say that? So you mean to say that update in what sense? Do you mean to say changing in the input data, or resulting in the output of the data, or What kind of update are we talking about? Yeah, changing of the data. Yeah, so changing of the data is in the form of input and output. So when we run something, it'll give an output, and this output is again stored in a separate file in HDFS. Okay, all right. All right. Kripa's question is, what if all the task trackers which are near to the data nodes are busy? Then the other machine, the other which are closer to the data node will be used. Okay. And if there is no data node available for work, then you get an error. All right. So Savita's question is, I believe all the activity is being tracked in the transaction log. Is there any GUI monitor dashboard to see the log details, or we have to do only in the Linux server to scan the physical log file? So probably you would be talking about this one. This is the GUI which shows you what's going on with the full activity in the cluster. Okay, you can see yarn map reduce here and all of that. Okay, that makes sense, Savita? All right, great set of questions. Moving ahead. All right, now the same idea when we combine it with MapReduce looks like this. Okay, so user copies all its input file, whatever data user wants to churn. First user will copy it to HDFS. HDFS is also called DFS at lot of times. Okay, and once we have copied that as an input file, it's ready here. The second work you will do when you are executing your MapReduce, you will submit your job via the client to the job tracker. So client will submit the job tracker. And let's ignore this aspect for time being, the create splits part. At this point, when the client has submitted work to the job tracker will find out, job tracker will find out which all nodes contain the file which client is trying to process. Okay, when in the job file, when client gives the job file to job tracker, client also mentions which file client wants to process. Okay, client clearly mentions it to job tracker saying these are the 5 files I want to process. Okay, now job tracker figures out that, finds out all the blocks of these files and hand it over to hand it over creates a job queue in which it will take the accounting of each of the work which is going to be assigned to each individual task tracker. So it will create like a job queue in which it will maintain the success status of each of the task trackers. Okay, and once it has done creating the job queue, it will assign the work to task trackers. Also, in case job tracker when job tracker has assigned the work to various task trackers, in case these task trackers fail, okay, in case these task trackers fail, what would happen in those cases? In case any of the task tracker fail, it will find out another task tracker having the near to the data which was given to the this particular task tracker. It will find out the same data set in the cluster and start the work on that task tracker. Okay, and ignore all the work done by this particular task tracker. If this task tracker has not responded to the heartbeats of job tracker, so job tracker has created a job queue. In job queue, it will maintain the status of the result being given by multiple task trackers. Okay. In case any of the task tracker fails, it will ignore the result of that particular task tracker and assign the same work to some other task tracker near to those blocks of data. Okay. So this is how the job tracker behaves. All right. Again, the same diagram. I hope this is clear to all of you. All right. Now, in case of Hadoop 2.0, earlier there was HDFS, and on top of it, we used to run only the MapReduce job. There was no other computation involved. There was no other computation involved. We used to only write MapReduce. Okay. Now in Hadoop 2.0, MapReduce, the whole system was broken into two parts. One was called yarn and other was called MapReduce. So basically Hadoop 2.0 said that MapReduce is just one paradigm of solving big data problems. Let's give space to other paradigms, and other paradigms, there were so many new invention happened in the similar manner as MapReduce. Okay. So Y- and the portion which basically takes care of job tracker task tracker kind of scenario became yarn, while running map and running reduce and then summarizing the data stayed as part of map reduce. Okay. Now if you can see that just because of this modularization, by breaking MapReduce into two parts, one called yarn and other called MapReduce. Yarn is yet another resource negotiator, meaning it tries to find out which nodes are free, which nodes having the data. Also, it tries to keep into account which nodes have been assigned recent work and so on. Okay, so all MapReduce and HBase and Giraffe and Spark and all of these systems started using started using Yarn to get their work done. Okay, just the way MapReduce was utilizing Yarn, just the way MapReduce utilizes the Yarn. Okay, so this gave a way to lots of. All right. Mandar's question is, could not see the name node in this block diagram. Okay. Name node is here represented by HDFS2. All right. All right. Kalva's question is Shisha's question is that is there the client or job tracker which asks the name node on which the data to process exist. Okay. All right, so the question is, who asks the name node where is the data, right? So Yarn knows about name node, and when these MapReduce hand over the work to Yarn, they inform Yarn to get only the nodes containing the data. Okay, and then Yarn basically knows HDFS and will ask name node and then get it done. So it is the yarn which will ask HDFS. So Michael's question is, what is the difference between yarn and MapReduce? Okay, it's like saying there is a database and database can run multiple different kind of processing. Okay, one of the processing is simply SQL. It can also run some other form of processing, while the internal way of managing the data remains same for all of them, maintaining the process. So Yarn behaves like an operating system which can manage the jobs, which can manage the process, which can do lot of things. And MapReduce is just one programming paradigm, as if we say that group by is one paradigm where we group by the data and give the results. So MapReduce is like that. A programming paradigm can be an SQL, can be in the form of MapReduce, and the programming paradigm could be like a for loop, while loop, and programming paradigm could be something like Unix pipelines. All right. Pawan's question is, why is it called HDFS2? Although there was not much of the changes in HDFS2 as compared to HDFS1, the only thing that changed was the backup mechanism. Okay, meaning the secondary name node or backup name node kind of a system. In HDFS1, it was not really highly available. If name node is down, then everything goes down. All right. Yes. Yes, Risha. It is the job tracker which finds out the location of the file. That's correct. Pawan's question is, so the normal way to interact with MapReduce is to submit the jar file at the command line. That's absolutely correct, Pawan. So the normal way to interact with MapReduce is you submit a jar file containing the code of map and reduce and hand it over to the Hadoop client, and that will basically run it using MapReduce. All right, so that was our diagram. Now earlier we had job tracker, task tracker. In case of Hadoop 1.0, the same thing became so many things. Okay, so task tracker became node manager, job tracker became resource manager, and these aspects were introduced in order to house various kind of systems, such as for MapReduce there will be MapReduce application master. For Spark there will be Spark application master. Okay. Or in other words, this diagram will give you an answer. So ta the task tracker became node manager, the job tracker became resource manager, container and application master were introduced. If you are using MapReduce, then MapReduce container and MapReduce application master will be utilized. Okay. All right. So this is the difference between Hadoop 1.0 and Hadoop 2.0. Okay. Now, a quick hands-on, we have already seen the web interface of Ambari and Hue. We have already accessed to cluster. We have already made directory on HDFS, and we can actually show you running the MapReduce command. Okay. So here our name node and is running name node and resource manager, which is job tracker, is running on Hadoop 1.0, Hadoop 1.nobigdata.com, while data nodes and node manager, that is task trackers, are running on all Hadoop 1, 2, 3, 4. Ambari, that manages the server, is running here. hue for which the developers interact with is running on this board. Okay, Ambari is an administrator tool, Hue is a developer tool. All right, you can do the connectivity like this. In case you have to copy some file from your local machine onto Hadoop 1 local or Hadoop 2 local, you can use WinSCP on Windows and SCP on Unix. All right. Now, from the command line, if you have to copy a file, you can use things like copy from local. Okay, from Hadoop 1's local file system to Hadoop 1 to HDFS. Okay, and if you have to check the blocks of the file, you can use this particular command, and you can change the replication factor of a file by using this command. Okay, so let's say we have this nice file. So we are saying Hadoop FS means HDFS. Copy from local means copy from Hadoop 1's local file system onto this folder in HDFS. Okay, it says the file already exists. So we can rename the file, my file 18 April to my file, what was the date? 11 July. Okay, and then all right, this way we have copied the file from our local file system onto here. Now we can have a look at the same thing from the file browser. If you go into Asgiri here, you can also click on edit and type on Asgiri. All right. Also, here you can see that the file has been copied from local. Similarly, we can also do a couple of new things, such as we can check the location of, we can say file 11 July.txt. What was the file name? My file txt. Yeah, so it shows you that the replication factor is 3, and these are the nodes containing the data. You can see that. Now, okay, now in case you change the replication factor to 4, okay, if you change the replication factor to 4, okay, so by using Hadoop fs minus set rep, you can change the replication factor, and here it will show you now. You can see now, you can see that there will be replication number 4, and these are the various node containing the data. All right, now if you try to set the replication as 5, we have 4 nodes, remember that, 4 nodes, and we are saying make the replication factor as 5. That means it will not, it will keep on telling you that it is under replicated. Okay, it is under replicated. It says that target replica set is 5, but found only 4 replicas. So the file is under replicated. All right. Make sense to you? So that's about HDFS. Now, a quick way to execute, I'm going to show you how to execute, although it wouldn't make much sense to you. All right. So I'm going to execute a MapReduce job of word count. That's probably the most popular thing. All right. So I'll just try to explain a little bit more about. All right. So here we are. Now, here we are saying Hadoop, and we are telling jar instead of fs, and we are telling that this is our program containing our MapReduce logic. Please execute this logic. Okay. And this is our input folder, and after the execution, keep the result here. And what are we trying to execute? We are trying to do a word count. Okay. And to do that, we can say things like this. You can basically execute a MapReduce job like this. It says that the output folder already exists. So we can say something like this. Okay, so it has started the process, and as soon as it starts the process, it gives a URL to track the job. Okay, so all right, so that pretty much explains it. All right, now tomorrow we will on the next Saturday we will discuss about how to think in terms of maps and reduces. Okay, and then we will go into the details of converting any problem into MapReduce. Okay, in case you are not very comfortable with programming, it's completely okay. You will be able to understand the whole logic easily, at least in the theory terms. All right. Now, question from Krupa and Srisha is what about app master and container? Let me try to explain it a little bit, or can we, or maybe we can explain it in the next session. But yeah, so application master is designed per application. One of the application of Yarn is MapReduce, other would be Apache Spark, other would be something else. Okay, so for each of these applications, whether MapReduce or Spark, they will create their app master, which will get executed on each node. Actual computation, actual processing work will be done by their application master. Okay, so per application there will be an application master, and there will be a container makes sure that application master does not cross the boundaries, or container also makes sure that whatever application master needs, container is able to provide it. Okay, you can think of container as if it's a small virtual machine running inside the node manager. So yes, Savita's question is, can I add new data node in hot deployment mode? Does it get added dynamically? That's correct. Yes, it gets dynamically added. Even you can do things like host, and here you can say add new host. And once you mention IP addresses, you can just say that add data node and these things on this machine, and the whole data will automatically get redistributed onto the new machine, new data node. Okay, and all of the big data tools are all of them designed with a scale out kind of a mindset. Scale out meaning that can keep on adding more and more nodes, and we don't have to shut down any of the machines. All right. All right, that's pretty much for today, and we will discuss the rest of it on next Saturday. Okay, sounds good. So, all of you have a great week ahead. I hope that today's session was interesting. Please feel free to provide the feedback at the end of the session. Okay, please provide the feedback at the end of the session when the form comes up. All right. Thank you, Hariharan. I'm happy that you found it wonderful. I'm actually quite happy with the audience. All right. Thank you, Priyavrat. Thank you, Savita. I'm happy this session was useful. Thank you, Damodaran. Good night, Damodaran. And thank you, Girish. Thank you, Kirupa. Thank you, Santosh. Thank you, Shrisha. Thank you, Praveen. Thank you, Anuj. Good night. Good night, Pavan. Have a great day. Great week ahead. All right. Thank you, Super Reddy. I'm happy that you liked it. All right. Great. All right. Have a great week ahead. And thank you very much.